Okay, we're now moving on to problem 9 in this set. So f of x is 7 to the power 2, which is in turn to the power 3x plus 1. So we can see that this is going to be the derivative of just 7 to the u if u is 2 to the power 3x plus 1. But 2 to the power 3x plus 1 can in turn be seen as 2 to the v, where v is 3x plus 1. So notice we're doing two substitutions, so it's a chain rule inside a chain rule. Basically a composition of three functions. So we want to take the derivative of 7 to the u, that's natural log of 7 times 7 to the u, times the derivative of the u. The u is 2 to the v, so the derivative of 2 to the v is natural log of 2 times 2 to the v. Then you've got the times the derivative of the v. The derivative of the v is the derivative of 3x plus 1, which is just 3. Now put the 3 in front with the natural log of 2, and then the natural log of 7, and then I've got a 7 to the u and 2 to the v. And substituting back in, u is 2 to the power 3x plus 1, and v is just the 3x plus 1. Now for a second derivative, this gets a little more complicated now. The first thing is the derivative of this. I'm just going to leave it in this form right here, 3 ln of 2 ln of 7 times 7 to the u times 2 to the v power, where the u and the v are the same substitutions as above. Now the first thing to notice is the 3 times ln of 2 times ln of 7 is actually all just a constant. So the first thing I'm going to do is just bring that out of the way. Now you see that we have the derivative of a product of two things, so we're going to use the product rule. The first times the derivative of the second plus the second times the derivative of the first. Both of those are exponentials, so we use the exponential rule. The derivative of 2 to the v is ln of 2 times 2 to the v times the derivative of the v. The v was 3x plus 1, so I went ahead and substituted that in here. Then the derivative of 7 to the u, I'm just going to leave it like that for the moment, because in the next step, when I do this derivative of v, it's 3. But the derivative of 7 to the u is what we started with. So it's just the answer right here to this previous one. I'm going to put it in this form right here. 3 ln of 2 times ln of 7 times 7 to the u times 7 to the v. Times 2 to the v, excuse me, at the end. Okay? And so now we can see what we can do is we might be able to do a little bit of cleaning up here. I don't really need that line. Now, what do we have here? Well, if we look, let's see. I see a 3 here in this term, and I see a 3 in this term. So I can pull that out front and multiply it by this 3 to get 9. I see an ln of 2 right here and right here. So I can pull that out front, combine with this ln of 2 to make ln of 2 to the second power. Okay. They both have a 2 to the v. See it here and here? So I can bring that out front. They both have a 7 to the u here and here. Okay, so when you pull all that out, what did we pull out? We pulled out the ln of 2, we pulled out the 2 to the v, the 7 to the u, and 3. We pulled everything out of this first one, so that just leaves 1 here. Out of the second one, we pulled most of it, but not everything. We pulled the 3, the 2 to the, let's see, we pulled everything that's in the parentheses here out, I think. The 3, the ln of 2, everything but the ln of 7. We pulled out. So we pulled out the 7 to the u, the 2 to the v, the ln of 2, and the 3. So we got the log of 7 left, and this 2 to the v is left. Because if we took this one out, this one's left. So we have that much left over. Now just plug back in to get everything back in terms of x, and we're done. So it's 9 ln of 2 squared times ln of 7 times 2 to the power 3x plus 1 times 7 to the power 2 to the power 3x plus 1. Then you have 1 plus ln of 7 times 2 to the power 3x plus 1. Okay, so that one used a chain rule inside a chain rule. We had to do two substitutions. F of 1, we go back to here, it's just 7 to the power 2 to the power 3x plus 1. And let's see, we plug in a 1 there. 3 times 1 is 3 plus 1 is 4. 2 to the 4th is 16, so this is 7 to the 16th. This is accurate up to the point where we hit all these zeros at the end. When I did this on my calculator, it went into scientific notation. When I do f prime, I'm looking at this formula right here, this formula, and plugging in 1 for x. So if you see that, that's this formula right here, where I plugged in 1s for x here and here. So once again, 3 times 1 plus 1 is 4. 4 and 2 to the 4th is 16, so that's this part. And this is again 7 to the 16th here. So I get, for a final answer, let's see, 16 times 3 is 48. So we get 48 times 7 to the 16th times ln of 2 times ln of 7. That's an exact value. Multiply that out, and we get this, and this is accurate up until here when we start hitting these zeros, so it's been rounded off. So if I want to find the tangent line, I take the slope, which is this f prime. Here it is, or approximately that huge number. So that number is the coefficient here. Then you have your x minus your x-coordinate of the tangency point, which is 1, so it's x minus 1. And then here we have the y value of the point of tangency, which is f of 1, which is right there. Okay, I have these graphed. Let's take a look at the graphs. Okay, had to play around with the window a little bit here, experiment to find out. And I used a window going up to about, looks like about 10 to the 15th or so. And I went from just -1 to 2, and I went down a little bit here, just a little bit below the axis. So the derivative, the original function, its derivative and second derivative are all above the x-axis. They're all increasing. They're all concave up. And then the tangent line is here, and notice it does cross or touch the graph here when x is 1, and it looks like it follows the curve. So everything appears to be okay with that one. For the next video, look at this number 10 here. Write that down now and work on it on your own if you haven't already, and then come back and check it with the next video.